December 22nd, 2032. This is the day an already detected asteroid could collide with Earth, and the impact would not be symbolic. It would be catastrophic. The object already has a name, 24YR4, a 60-meter space rock with enough energy to destroy an entire city in seconds. Scientists have classified it as potentially hazardous. But what does that really mean? No one is explaining clearly. If something so small can cause so much devastation, why do they still treat this as a technicality? Simulations are being carried out. There are maps with possible impact zones, but there is also silence. A silence that only increases doubt. Are we facing a controlled risk or a future programmed for disaster? Comment below. Do you think we are being informed or prepared without realizing it? Because what you are about to discover now could completely change the way you view the control we have over our own planet. On April 11th, 2024, telescopes from the University of Hawaii's Atlas system detected a new moving dot in the sky. It was small, fast, and on a trajectory that required immediate attention. After preliminary orbital analyses, this object was given the designation 2024YR4. Initially, it might have seemed like just another rock among millions wandering through space, but the mathematics behind its path raised alarm bells. It was heading toward us at a level of approach considered rare and risky. What caught the attention of experts was the combination of speed, mass, and predicted entry angle. These factors together are what define the destructive potential of a celestial body. 2024YR4 has been officially classified as potentially hazardous by NASA, which means that its orbit intersects Earth's at a point close enough to justify constant monitoring and priority in trajectory updates. This status is not common and is only granted when the margin of error in calculations could literally cost lives. It belongs to a class called NEOs, near-Earth objects, and more specifically, it belongs to the group of Apollo asteroids, which have orbits that frequently cross Earth's orbit. This in itself is already worrying, but the most disturbing factor is the instability of orbital data in the early stages. Small inaccuracies or natural changes caused by heat, rotation, or even internal fragmentation can alter the path of this object in a matter of months. And in this case, millimeters of deviation in space can mean kilometers of impact on Earth's soil. But that's not the only variable that worries scientists. There's an additional uncertainty, little discussed outside of technical reports, that could redefine everything we know about these celestial bodies. The term city killer was coined not by Hollywood screenwriters, but by scientists studying the destructive potential of certain asteroids. The term refers to objects large enough and energetic enough to completely obliterate a medium-sized city without necessarily causing global damage. What makes this so alarming is the fact that these asteroids are small enough to escape early detection, but large enough to cause irreversible tragedy on a regional scale. To understand the magnitude of the impact, one need only consider a real event: the Tunguska earthquake in Siberia in 1908. An atmospheric explosion caused by an object with dimensions estimated to be close to the profile of a city killer devastated more than 2,000 square kilometers of forest. Trees were uprooted like toothpicks, charred animals disappeared, and the shockwave was recorded at seismic stations thousands of kilometers away. The effect of a direct impact on an urban area would be exponentially more catastrophic. The release of thermal energy would incinerate everything within a radius of several kilometers. The shockwave would shatter glass, collapse structures, and generate lethal atmospheric pressure. The destruction would come not only from the point of impact, but from everything that the impact would trigger within seconds: chain fires, electrical system failures, and widespread chaos. All of this caused by something that, in astronomical terms, is considered small. But what few people understand is that the real risk of these objects is not just the force of the impact, it is the way they enter the atmosphere. A specific angle, an above-average speed, and even the composition of the asteroid can turn a localized event into a historic catastrophe. And there is a little discussed factor that can amplify this effect without any prior warning. When NASA announced that the chance of asteroid 2024 YR4 impacting the planet had dropped from 3.1% to 0.28%, many people breathed a sigh of relief. But this relief hides a common mistake: confusing low probability with certainty. In events with catastrophic consequences, even fractions of a percentage represent a concrete and real risk. The difference between 3% and 0.3% seems huge, but in practical terms, we are still faced with a real possibility of a collision. And that should be enough to raise alarm bells. The math of catastrophe doesn't work like it does in regular betting. If you knew there was a 0.28% chance your flight would crash, would you board? Probably not. Now imagine that risk applied to an impact that could kill tens of thousands of people in seconds. In a world where the unpredictable is the rule rather than the exception, a low percentage should not be ignored. It should be taken more seriously precisely because it is rare and devastating. Furthermore, these projections are not definitive. They change based on new data, simulations, and updates to orbital models. And herein lies the most disturbing point. We are dealing with complex systems, uncontrollable variables, and a margin of error that, no matter how small, is enough to change the fate of an entire planet. An asteroid's orbit can be altered by minimal factors, such as solar radiation pressure or the gravitational influence of other celestial bodies. It's like watching a chaotic dance between calculations and uncertainties. One simulation shows the deflection, another the collision, and behind these cold analyses lies an uncomfortable reality. No one can say with 100% certainty what will happen. And this raises an inevitable question. Is the real danger in the asteroid, or in our trust in statistics? The idea that an asteroid could hit Earth on a specific date triggers something much deeper than the fear of physical destruction. It shakes our sense of control. We live believing that tomorrow will always come, that the future is guaranteed by schedules, bills, and promises. But when a cosmic threat looms, even from afar, all of that begins to seem fragile, almost illusory. The psychological impact goes far beyond collective panic. It infiltrates in subtle ways, in jokes about the world ending before Christmas, in ironic phrases like, "I'm going to sell everything and disappear," and even in the calculated indifference of those who say they don't care. But behind this lies a defense mechanism. The brain tries to rationalize the irrational. After all, how can we deal with something that we can't face, run away from, or ignore for long? Psychologists call this cosmic anxiety. Discomfort in the face of the immensity of the universe and our total powerlessness in the face of it. The awareness that a simple space rock can redefine everything we know awakens insecurity, disorientation, and even impulsive behavior. That is why, when faced with this news, many laugh, others remain silent, and some begin to question everything. Now tell me, do you think we are psychologically prepared to accept that everything can end not because of our choices, but because of something that comes from space? Comment below. We want to know how far your vision goes on this human fragility in the face of the unknown. And while everyone tries to deal with it in their own way, there is something even more disturbing. In the midst of this collective uncertainty, the coordinates continue to be calculated. But what if a small error was enough to redefine the entire destiny of an entire region of the planet? If asteroid 2024 YR4 does indeed collide with Earth, the most likely impact scenarios have already been mapped out. Simulations indicate critical risk bands passing through the eastern Pacific Ocean. regions of South America, areas of India, and parts of Africa. But anyone who thinks that the effects would be limited to the point of collision is mistaken. When we talk about a planetary scale impact, the impact site is just the beginning. An impact in the ocean would generate an instantaneous release of energy equivalent to tens of megatons. This force, when it hits the water, transforms into gigantic waves, tsunamis, that could propagate thousands of kilometers, reaching continents within hours. Entire coastal cities could be swallowed up before any emergency response could be made. And it doesn't stop there. The mass of dust and vapor released into the atmosphere could obscure sunlight for days or weeks, interfering with global weather systems. A sudden cooling in strategic regions could cause agricultural collapses, destabilizing economies and directly affecting food supplies. If the impact had occurred on land, the shockwave effect, the rise in local temperatures, and the displacement of soil would have caused total destruction for tens of kilometers. But the worst would have been the chain reaction. Infrastructure collapsing, communication networks failing, populations fleeing, and widespread panic spreading in record time. The entire world would feel the consequences, not just those at the epicenter. And that's what makes this threat so alarming. The impact may happen far away from you, but the effects arrive before you know it. Now think, what if these risk areas are miscalculated? What if the real target has not yet been identified by our instruments? Faced with the threat posed by objects like 2024 YR4, humanity began testing practical methods to deflect an asteroid. For the first time, in 2022, the NASA-led DART, Double Asteroid Redirection Test mission, managed to hit the asteroid Dimorphos with a direct impact, altering its trajectory. It was a historic success, the first real test of planetary defense, but there is a critical difference between theory and practice. Dimorphos was part of a binary system and posed no threat to Earth. Hitting a real target at real speed with real consequences is a whole other level of challenge. Orbital accuracy, launch window, response time, and object mass are all variables that can make a retry more difficult than it seems. Furthermore, a direct hit isn't always the best option. Some scientists advocate less aggressive alternatives, such as using gravitational pull, putting a massive spacecraft alongside the asteroid long enough to gradually pull it into a new orbit. The problem? That requires extremely advanced continuous propulsion technology and nearly unlimited resources. And this is where the speculation comes in. Elon Musk and other influential tech figures have suggested solutions involving artificial intelligence, autonomous spacecraft, and real-time global coordination. SpaceX, with its fleet of reusable rockets, could, theoretically, launch multiple impact missions quickly. But even with all these advances, the most dangerous factor is still time. Any response depends on knowing the threat early enough. The question that persists among experts is straightforward. Are we really in control, or are we simply relying too much on systems that are still far from infallible? It's easy to feel reassured when the numbers tell you what you want to hear. The probability of an impact from 2024 YR4 has dropped from 3.1% to 0.28%. Sounds like a relief, right? But that sense of security can be its most dangerous trap. Science works with margins of error, and when it comes to moving celestial bodies, all it takes is a recalibrated calculation, a new orbital reading, or a change in trajectory caused by a smaller, unseen body to change everything. A small adjustment can mean the difference between a gentle flyby and a direct hit. And while space agencies take their jobs seriously, weather and space are not completely predictable systems. With each new analysis, new data is added. With each telescope connected, there is a chance that something that has gone unnoticed will finally show up. The problem is that we rely too much on a system that still relies on constant updates to keep us informed. The supposed security is not the result of absolute control, but of continuous monitoring and statistical models, which, by definition, deal with uncertainty. And in extreme cases, even a 0.1% risk is a red flag. Because the impact doesn't need to happen frequently to change everything, and that's why this discussion needs to go beyond the numbers. The only thing more dangerous than an asteroid on a collision course is the false sense that nothing will happen. This is something few people know. Share it now with anyone you know who is fascinated by the mysteries of the universe. And help spread this discussion before it is overshadowed by the silence of statistics. But while humanity watches the sky for errant rocks, perhaps the real question that is being ignored is another. What if what is coming is not just a rock? There's a disturbing idea that's been floating around in science, philosophy, and science fiction, that the Earth at certain times seems to hit an invisible reset button. Mass extinctions, abrupt climate shifts, entire civilizations wiped off the map. It's all happened before, and the geological and archaeological record confirms it. What's intriguing isn't the suit itself, but the frequency with which these cycles seem to occur. Some theorists hypothesize that humanity, at deep levels of collective consciousness, feels out of control, and it is as if part of us wishes, even if silently, for something bigger to intervene and force us to start over. A forced restart, a global reset. This feeling is heightened by the growing chaos, wars, environmental collapses, social degradation, and superficial hyperconnectivity. The idea of a cosmic event that disrupts everything stops being merely frightening and begins to seem to some a form of natural justice, as if the universe, in its impersonal complexity, responds to imbalance, with an impact that rearranges everything. Of course, some people see this as fiction, others see it as prophecy disguised as science, but somewhere in between these two extremes lies a disturbing point. Earth has restarted before, and there's nothing stopping it from doing so again. The difference is that this time we're here, and maybe we're part of the problem, or part of the chance to prevent the next collapse. And even if that reset never comes from space, the question remains: how long can we continue to live as if there were never any consequences? Something in this equation has yet to be explained. And perhaps the real answer lies hidden where no one is looking, in that which moves, in silence, beyond what we can detect. The universe never promised stability. It spins, collides, pulsates, indifferent to our calendar, our plans, our systems. A single rock drifting through space, carrying speed and direction, can be enough to remind us that in the end, we are not the ones in control. Whether it is in 2032 or 1,000 years from now, the impact may come. And when it does, it will. Not matter what we have built or how far we have come, everything can be reset in seconds. But between the threat and the impact, there is a gap, a space of time. And it is within this gap that what really matters lies. What we do, what we choose, what we prioritize. The asteroid haunts us not only for what it can destroy, but for everything it reveals about us. Our denial, our arrogance, our faith, our rush to forget or to laugh, as if laughter makes us immune. And maybe, just maybe, we are not alone in this ordeal. Maybe there are eyes watching, not to interfere, but to understand. How we respond to the threat says more about our species than any historical record, because the real impact may not be physical, it may be psychological, cultural, spiritual. So the question that remains is not when, it is let's answer. And now, if you feel that this type of reflection needs to continue in your life, that this type of content makes you see beyond what your eyes can see, then be a part of it. Here, each new theory, each new piece of evidence, Each bold hypothesis is a key to unlocking yet another of the infinite secrets of the universe. Subscribe and turn on notifications, because understanding the cosmos is a privilege, but being part of those who seek to understand is a choice. And before you go, one last provocation. What if what's coming isn't an asteroid? What if it's not just a rock? Now click on the video that is appearing on your screen. There is something there that can change the way you see everything we have discussed so far.